SNMP, Simple Network Management Protocol, if poorly configured or left to its defaults, is a very easy way for you and I, or an attacker, to collect tons of information that can be valuable as part of our enumeration process. Many devices on our network support Simple Network Management Protocol, or SNMP. Not every one of them, but many of them do. And some of the details regarding SNMP is that it uses UDP, User Datagram Protocol, which is connectionless, and it uses port 161, and that's for general SNMP administration, and it also can use 162 if there's a trap. So let's say, for example, that this router right here, router 1, has been configured with SNMP, and that you and I are sitting right here at our management computer. So at our management station, we can make requests to the agent, the SNMP agent running on this router, and then get responses. And that would be done using UDP 161. If we configure router 1 for traps, where it generates messages to send over to the SNMP manager, for example, when a threshold has been exceeded, that'll be using UDP port 162. In the world of SNMP, there's something called an OID, which is an object ID. There's also something called a MIB. Now, the MIB is the Management Information Base. That's the collection of stuff, if you will, that we can look at or monitor or change via SNMP. And the way all the individual objects are identified in the MIB is through the object IDs. So, for example, this router may have 300 different small elements that it can report on. And each of those elements can have their own individual object ID. And the challenge is, if the SNMP manager wants to learn about one of those specific details, it can go ahead and do so by simply making a request regarding a specific object ID, at which point the router will respond with just the information requested. Now, unfortunately, regarding defaults, there are default quote-unquote passwords. They refer to these as community strings, and the default password or community string for reading information from an SNMP agent running on a device, the password is public. And sometimes we'll see it as a RO for read only. And the default community string for read-write capabilities is called private. And the challenges regarding these community strings or quote-unquote passwords is that not only are they predictable if we leave the defaults in place, but also they're sent and received in clear text if we're using the early versions of SNMP. So an attacker who's eavesdropping on the network could discover what those passwords are simply by looking at the network traffic. So that's one of the reasons that SNMP version 1 and version 2 is vulnerable to attackers, is that if somebody's sniffing the network, they can discover those passwords and then start using them. There's also a process called walking the tree. And an example of doing SNMP walking would be the management station making a request saying, please show me everything you have. At which point the agent, the SNMP agent running on this router, would then report back all the details for each and every object in the MIB. And regarding being secure with SNMP, we should use version 3, which supports authentication and encryption and data integrity when it's configured correctly. And in addition, we also want to set up some filtering. So we can tell, for example, a specific host that's running SNMP that it should only be communicating with a specific IP address or a specific range of IP addresses, which would represent our management stations. That way the attacker coming from an IP address outside of that range wouldn't even have the opportunity to make SNMP requests, even if he had the password. Now, a tricky hacker might do this. If the hacker has knowledge that the SNMP is only allowed from host 192.168.1. Let's say 50, and that's the only IP address that the router has been configured to play with regarding SNMP, what the attacker could do, let's go ahead and put our attacker right here. And for this example, we'll assume that he's got a compromised host somewhere here on the local area network. The attacker could send in spoof packets that appear to come from .50. And when the router receives them, he's going to respond back to .50. And the problem is, if the attacker wants to see that response, the attacker would then have to go ahead and sniff the network and eavesdrop on that reply traffic so we can see the responses that are coming back to the management station. Or the attacker could perform some type of a man-in-the-middle attack, at layer 2 in this case, with spoofed layer 2 addresses, so that the responses that are supposed to go to .50 actually go back to the attacker's layer 2 address, and that's another way that he could look at that information and process it. And if an attacker is doing a scan, for example, of the entire network and looking for example, UDP port 161 that's open, and maybe there's 5 or 6 devices that have that port open, the attacker could then try against those 5 machines using the default password, the default community string, to see if the device responds. And if there's no response from a device, there could be several reasons for that. One, maybe we have the wrong community string, they've changed it from the default. Or perhaps there's some type of a connectivity issue. If we did get the scans on the 5 devices, we probably have connectivity on that port to that device. But if we're doing a blind SNMP attempt to connect to a device, it very well could be that we have no connectivity over to that IP address. And another option is the device we're trying to connect to perhaps maybe doesn't really have SNMP services running. And those are 3 reasons why, if we're doing an SNMP GET request, for example, to an SNMP agent, that we might not get any response. Now, in practicing and setting up for this demonstration, I added a Cisco router called R1 to the 192.168.1 network, so I have him physically connected to the network, and his IP address is .151. And then I thought to myself, if someone is doing this in their home lab, which by the way I hope that you are, they may not have a router that they can simply plug in, whether it's in GNS3 or a physical router that supports SNMP. So what I also want to do is I want to walk you through how we can take our 2012 server and let's enable SNMP on it as well. And that way, as we do scans, you can discover at least one SNMP device in your lab environment, and that'll be the 2012 system. So here's our game plan. We'll enable SNMP first on the 2012 server. We'll then go ahead and use some tools to scan our network for SNMP. And then together we can enjoy the fruits of our labor by seeing the wealth of information that SNMP is just pouring out to the hacker. So here in our virtualized environment, I've got Windows 10 running, the 2012 server running, and the Kali Linux box running. Let's go over to the Windows 2012 server. I'll bring it up full screen, and we'll log in. Also here in VMware Workstation, to submit a Control-Alt-Delete, we're going to do Control plus Alt plus Insert, the Insert key, and that will pass in the Control-Alt-Delete to our virtual machine. And with that done, we'll log in with our lab password. And that brings up Server Manager by default. What we're going to do is we're going to enable SNMP services on this Windows 2012 server. And to do that, in the upper right-hand corner, we're going to select Manage. And then from the drop-down, we're going to select Add Roles and Features. And then we'll click Next a few times. And what we're after is we want to go to this area right here, Features, and then scroll down this list till we get down to SNMP. So we'll go ahead and scroll down. It's alphabetical. And there's SNMP service. We'll simply put a check in that checkbox, click on Add Features, click on Next, click on Install, and then when it's done, we'll go ahead and click on Close. In fact, we could click on Close right now. It would still continue, but I just want to make sure that it's going to complete. And it's done, so we'll go ahead and click on Close. The second thing you and I are going to do on this Windows 2012 server is set up the community strings, the passwords. And to do that, we're going to go up to the Tools menu here in Server Manager, and from the Tools drop-down, we'll select Services. And then from here, we'll scroll down in the list of services, which are currently sorted alphabetically, and we'll go down to SNMP. So there's the SNMP service. So we'll right-click on the SNMP service, and from the drop-down, select Properties of the SNMP service. And then we'll click on the Security tab, and we'll go ahead and we will add our community strings. And for read-only, I'm going to use the default community string for SNMP version 1 and 2, and that is public. And click on Add, and I'm also going to add a community string for read-write access. And that community string we're going to use as private. Again, those are the defaults for SNMP version 1 and 2. Also, I'm going to tell this device to accept SNMP packets from any host. So this is an example of, please don't do this. We don't want to use default community strings, and we don't want to leave wide open access so anybody can send SNMP requests to this device. But for the lab, I'm going to open it wide up, and we'll click on Apply. And if we go over to Agent, we can also specify for service that we want to include the physical information, data link, and subnetwork as well as part of the service, and click on OK. And so we'll go ahead and close that. And now we've set up and enabled SNMP on our Windows 2012 server. Now also in my lab, because I do have a router that I powered on for this demonstration, let me show you the configuration for a router that's also cconnected to the 192.168.1 subnet. So this is a Cisco iOS router. If we do a show IP interface brief, which is a Cisco command saying, please show me your IP address information. It's got lots of interfaces, but this is the one I want to focus on for the moment, 192.168.1.151, and it's currently up. Also, if we do a show SNMP and press enter on this device, this indicates that SNMP is currently running on this device. And if we do a show run and look at the output of the configuration on this router, it's got quite a bit of stuff here, but the part I want to focus on is the SNMP configuration, which is right here. So this line, this first one here that we're looking at is SNMP server community public RO1. Now, in English, what that means is that the community string, the password, if you will, for read-only access is public. That's how this router is currently configured, and this 1 represents access control list number 1, which means that this router will only accept SNMP requests using this string of public from devices on the 10.1 subnet, 10.2, 10.10, and the 192.168.1 subnetwork. So if the attacker knew that and wanted to send SNMP requests to this device, the attacker would either have to be on one of those subnets or appear to be on one of those subnets. And then the second line here is the community string of private that has been set for read-write access, also with the access control list number 1 in place. So now we verified two things. The Server 2012 server is running SNMP, and our Cisco IOS router is also running SNMP. In this nugget, we've taken a look at the basic concepts of SNMP. We've also prepared our lab environment to verify we have a couple of SNMP devices that can be discoverable on our network. And in our next nugget, we'll take a look at the tools to help discover and then enumerate those devices based on SNMP. Until then, I hope this has been informative for you, and I'd like to thank you for viewing.